Today we're going to cover calculating odds. The odds of an event A is the ratio of the number of ways A can occur to the number of ways A won't occur. So here we have the odds of A is the number of ways of getting A to the number of ways of not getting A. Similarly, the odds against A would be how many ways we won't get A to how many ways we will get A. So let's take an example. Let's say we roll a die. Let's find the odds of getting a 2. Well, we know there's one way to get a 2, and there's 5 ways to get anything else. So if we look at the odds against getting a 2, we're just going to flip that around, and we can say there are 5 ways not to get a 2 compared to the 1 way to get a 2. Keeping this idea of rolling a die, let's look at the odds of getting a number less than 3. Well, we have 6 numbers, 1, 2, 3, 4, 5, 6. We can see 1 and 2 are less than 3, so there are 2 ways to get a number less than 3. And then we still have 4 numbers left over, so that's 2 to 4. Just like we do with fractions, we reduce odds as well. So 2 and 4 are both divisible by 2, so we want to make that 1 to 2 as our final answer. Just let's flip that around. The odds of against getting a number greater or less than 3, we're going to change that to 2 to 1. Select a card from the ones pictured on the left. So what do I have? I have the ace, king, queen, jack, and 10 of hearts, so only 5 cards. I want to know the odds of drawing a face card. So our face cards are the king, the queen, and the jack, so that's 3 cards. And then I have 2 left over, the ace and the 10. Let's look at the odds of drawing an ace. Well, we have 1 ace, and we compare that to the 4 other cards. Now let's say the odds against drawing a queen. So we don't want to get a queen. So that says there are 4 cards that are not a queen to 1 card that is a queen. I want you to see this is different than doing probability. If I were doing probability, the probability of not getting a queen would be 4 over 5. I want you to see this difference of really like the second number. So here the second number is the whole. It's how many cards did I have all together. And when we're doing odds, the 2, the 4 and against, like the 4 and the 1, come up to the whole 5. So make sure when you see odds, you think, I'm not doing probability, I'm doing something else. Do not put the whole in the denominator or in your ratio. So now that we've seen how to do odds, we want to be able to go back and forth from odds to probability and probability to odds. So let's start with odds to probability. If the odds of an event A occurring are A to B, then the probability of A occurring is A over A plus B. So odds A to B becomes A over A plus B. This is what we want from this slide. Let's try this. Find the probability of rain given the odds of rain are 3 to 1. So what does this say? This says for every 3 ways that it will rain, there's going to be 1 way that it won't rain. So for our probability, I put 3, and then on the denominator, I do 3 plus 1, which is 3 out of 4. Now, 3 out of 4 makes sense to us. This is 75%. So if somebody tells you there's a 75% chance of rain, you know it's really likely, and I think sometimes you understand probability better than you understand odds. Let's look at a second example. The odds of a candidate A winning an election are 1 to 10. Find the probability that they win. So there's 1 way the person's going to win. Over the 1 plus 10, 11 things that could happen, so I have 1 over 11. The odds of candidate A winning an election are 3 to 7. We're going to find the odds that candidate A wins. So we take the 3 on top, we do 3 plus 7 on the bottom. This gives us 3 over 10. Candidate B, it says the odds are 2 to 5, so we put 2 on top and 2 plus 5 on the bottom, so this is 2 over 7. With both of them, we could leave it as a fraction if you like as a decimal better. So that's 0.30, which is 30%. The 2 over 7 isn't going to come out as nice, so let's just estimate it to 4 decimal places. So that's 2857 or 28.57. Really pay attention to what's asked from you. Are you asked to give a decimal? Are you asked to give an integer? Are you asked for a percent? So it says the number of employees by gender and job status, full-time or part-time, is summarized above. If a person is selected at random, find the odds of selecting a woman. So look at our chart. We have 170 women to 230 men. We have these two zeros, they can cancel out, so I end up with 17 to 23. Let's look at the odds that someone's part-time. Okay, so looking across, part-time was 150. Anybody else would be full-time, which is 250. I'm going to reduce this a couple times. First thing, let's get rid of those zeros again. Now I have 15 to 25, but those are both divisible by 5, so 15 divided by 5, 3, 25 divided by 5, 5, so here's our 3 to 5. Now let's look at a woman employed full-time or a man employed part-time. So a woman full-time, so I look right here, full-time women, there's 65, or a man part-time, that's 45. So I have 65 plus 45, that's my first part. And then I compare it, well, what's left? The men full-time, 185, and the women part-time, that's 105. So let's start with adding these together. 65 and 45 is 110. Then I have 185 plus 105, which is 290. Okay, cross out the 0, cross out the 0. I have 11 to 29. This says if the probability of A is A over B, then the odds of A will be A over B minus A. Let's kind of work that through to say how would I write it? I would write A to B minus A. Okay, so I can do a ratio again. Let's look at that. If the probability of getting an A in a class is 9 over 20, then the odds will be 9 to 11. So how did I get there? I said, well, there's 9 ways that the person's going to get an A, but then how many things are there left? There's 20 minus 9, so this is 9 to 11. Well, what if the probability of failing a class is 1 over 6? Well, that says for every one way to fail, there are 6 minus 1 ways, which would be passing, so that gives me 1 to 5. So I'm subtracting the numerator from the denominator to get to the odds. Let's say the probability of getting a B in a class is 10%. First thing I want to do is say, well, 10% is like 10 over 100, right? Percent means over 100. I'm going to leave it that way. So now I have my 10 over 100, which says for every 10 ways that somebody gets a B, there are 100 minus 10, which is 90 ways that they won't get a B. So the 0 cancels the 0. I get 1 to 9 as the odds of getting a B. Let's look at eye color. What are the odds a person has blue eyes? So when I look at this picture, I can see blue is 32%, so let's write 32. Well, and then you have to think then what's left over. So you could do 100 minus 32, which gives me 32 to 68. We can look at 32 and 68 and think, well, they're both definitely even. I could divide by 2. That would give me 16 to 34, which says I could divide by 2 again, and I would get 8 to 17. What are the odds a person does not have green eyes? So green was 12%. So that way, that times is 8. Like not green, I do 100 minus 12, which is 88, to the green eyes, which is 12. Okay, 88, 12, let's divide by 4 this time. So 4 would give me 22 to 3. What are the odds a person has brown or dark brown eyes? So brown or dark brown, I have 25 plus 16, that gives me 41%. So 41, and then I compare it to 100 minus 41, which is 59. Let's look at a chart. So here this chart says a survey of 500 people revealed the number of dogs they own. If a person is selected from the group at random, let's find the probability the person has at least one dog. Okay, at least one dog means one dog or more. So here I have 1, 2, 3 or more. So one thing we need to know is remember that we have this total of 500. So 320 people have no dogs. That means the rest, 500 minus 320, which is 180, have at least one dog. That's the same as adding the 125, 40, and 15, just going a different way. So we're looking at the probability the person has at least one dog. So 180 over 500. Let's do 180 divided by 500. This gives me 0.36, which is 36%. Now let's do the odds just to make sure we understand what's probability and what's odds. So the odds that a person has at least one dog, well, we still have the 180 that have at least one dog, compared to the 320 that do not have a dog, right? They have 0. We've done this a bunch of times now. I get rid of the 0. I have 18 to 32. I know they're both divisible by 2, so I can do 9 to 16. We can see a big difference in the expression, right? We can see 36% of people have at least one dog compared to 9 to 16 as the odds. So you just want to make sure anytime you see odds, you kind of slow yourself down. You don't put that whole number in the denominator and you do for and against.